Hi everyone, myself Bhagyashree and today in this video I am going to discuss about the HRD, which is very important part in the system design, and the concept I am going to discuss here and sharing the information and knowledge about that, which will be a fundamental and very necessity if you are looking for this system design concept, system design interview. This concept should be know before appearing for the interview or before creating any application regarding that. I can say the system design, so that will be a beneficial. So let's start over there. And before starting, I just want to please like, share and subscribe this channel. It will be help me, and we'll create the such content, more such good content. And in the upcoming video also, if you want some upcoming video which we can discuss or which have any doubts, please comment it down. I will try to make solution over there in the upcoming video. Thank you. So let's start with that. Okay, so in the HRD, it is like we in the system design, basically we have a two types, HRD and LLD. So in the HRD class, what we can say, it is a high level design for creating any application or any system design. The concept which we have to be know as a fundamentally, that will be I am going to discuss here. First on that, we can say we have one of the like forward proxy. So in the forward proxy means like a proxy server, like a middleman between your computer and the internet, and it help control the internet traffic by following the specific rules. Like it can change your computer's identity, make sure everything is safe, and stop any unfamiliar data from the coming in. So that is for the forward proxy we have in the system. Next, we have a reverse proxy. As we have a forward, so similarly, we are having the reverse proxy concept also. In the reverse proxy means it is a special type of helper server. It works behind the scene to protect other server from direct contact with the outside world. When you ask for the something online, you talk only this helper server, and this find the right server to get the what you what you want, and send your request there and bring back to the answer to you. You don't even know another server was involved. Just for the example, I'm searching anything on the web, Google, or I'm just shopping any product on the Amazon website. So it will be first goes on this reverse proxy, then it will searching like which request I want to go for the mantra or I want to go for the Amazon site. Basis on that request is goes to the server and sending the response to other, again in the client side. So that is a reverse proxy. You can see in the picture also. In the forward proxy we have, when the client is coming, he uses the forward proxy, then from this forward proxy it goes to the internet, and this will be go in the main server. Coming to the reverse proxy scenario, for going to the main server, we have to first client interact with the internet. The internet will be searching like on which request which server have to be performed the response over there. Basis on that, it will be going on that level, on the server level, on main server. Okay, right now we have idea about the reverse proxy and forward proxy. Now we have to be like, what is the any key point difference between them? They are having some difference over there with the load balancer. So in the reverse proxy, like it is a accept a request from a client, forward to the server that can fulfill it and return the server response to the client. It is a reverse proxy. In the load balancer, what we can say, load balancer nothing but it is like distribution incoming client request among a group of server, and in each cases returning a response from the selected server to the appropriate client. It is basically when you have a lots of requests. For the same example I am taking, for the Amazon website, when we have a festive season, some offer, some discount is going on, so most of the user, most of the end client, they are buying the product from there. So on that scenario, for the request is coming multiple, sometimes maybe having a heavy traffic over. So what we can do for the good response time purpose, for the scalability purpose, we are using the load balancing. Load balancing is nothing but it is a distributing the our request to the different server instance. Like we have a 50 request for the example, so I can distribute the 10 request for the 5 server. Okay, then we have a layer 7 load balancer, a type of reverse proxy. and load balancer only needed when we have a multiple server. When we have to be use a load balancer हम तभी use कर सकते हैं when we have a multiple server. Like reverse proxy can be used even with a single server, but for the load balancer we need multiple server because we are going to the distribution of that request. Like load balancer का मतलब ही होता है you have more than one server, more than two server. That's why this load balancing concept is coming. Okay, so like you have a multiple request coming over there for the scalability, for availability, for the responsiveness purpose. You have to be load balancer. Load balancer we have a more than one for the instance distribution or for the request distribution for the system level. But reverse proxy cases can be used even with the single server. So that is the load balancer concept. Now after the load balancer we have a API gateway. As our name suggests, gateway means क्या होता है कि when we are going some place, the main task is like we have to be enter into the any organization or any garden or any house. First we have to cross the gate, then we are allowed to enter. Similarly here also API gateway also, when we want to communication for the response purpose, we have multiple services over there. So for interacting for that services purpose, this API gateway is a very useful. It acts as a single entry point for all API requests and provide the features such as request routing, rate limiting, authentication, and API versioning. Basically, it is used in the microservices architecture most of the time because microservices communicating more than one services. So on that scenario, this API gateway we are using, and for that we have a like request routing means which server have a like when we are requesting something, so which API will we get called first, and from the calling purpose when the request is coming, for the request is going and response is coming, so on which API server API services have to be load. Then we have a rate limiting also, and for the API we have authentication authorization mechanism also. So all the stuff we are maintaining in the here in the API gateway, and it also hide the like complexity of the underlying microservices from the client application because it is a gateway. When end client want to see like each microservices, what is the logic behind that, what is they are actually doing as a as he want to see, but because of this it can't be possible. It is a level of I can say one of the abstraction type. Now we have a like reverse proxy, load balancer, and API gateway. Now we can compare all these three. What is the difference between them? What is the primary function over there? Compare all these three and see like which is suited for the which scenario or best suited for the which application purpose. So let's start with that. In the reverse proxy, for the primary function, we have handle the request from client to server, providing the security, SSL termination, caching, and content manipulation. So this is that primary function of the reverse proxy. API gateway act as an entry point for APIs, providing features like API authentication, rate limiting, request response transformation, and logging. Third, we have a load balancer. Distribute incoming network or application traffic across the multiple server to optimize the performance, ensures the high availability and reliability. That's why this load balancer we are using. Coming to the like traffic direction, when we are using any services, we have to be see like the request is coming from which side. Handle the request from client to server in the reverse proxy. In API gateway also we have a client request to API, and load balancer scenario we have a distribute traffic from the client among the multiple server. So we can see the most of the time the request is coming from this client side direction. Traffic is coming from the client side directions. Then we have a client interaction. So client interaction in the reverse proxy, client communicate directly with the reverse proxy with forward request to server, and client are the not aware of the backend server. So this is the what I can say sugar behind that or good point about that in the reverse proxy because you don't have idea about the behind the server. Coming to the API gateway in that way client interact with the API gateway and which then routes request to the appropriate API, like which API route will be called first, and basis on that request is gone, a response is coming from this API level. In the load balancer, we have a client interact with the load balancer, which is then distribute the request to the appropriate server. Coming to the like content handling on all this scenario, and in the reverse proxy, we can for the content purpose we can modify content, perform caching, and handle the SSL termination. And in the API gateway, we can handle the request response transformation, enforce API security policy, and provide the response caching, because we are doing already authentication mechanism here. In the load balancer, focusing on the distributing traffic efficiently and ensuring the server health, content manipulation tasks are usually handled by the reverse proxy or API gateway. I can say in the load balancer, our aim to be like any server should not be have to be downtime, have to be health check. Like if anything is we can see or detect any issues on any server level, we have to be capture and catch the thing and problem resolve as soon as possible. Coming to the like security point of view, SSL termination. In the reverse proxy, we can handle the SSL TLS encryption decryption on behalf of the backend server, offloading this task from the server, I can say. But in the in the API gateway, we have SSL TLS termination, ensuring the secure communication between the client and API. And in the load balancer, we have can SSL termination, offloading the task from the backend server, ensuring secure communication between the client and server. Okay, after all the stuff, the main important task about any application is security. For the handling security mechanism, in the reverse proxy, filtering like malicious requests and protecting server from the direct exposures, enforce API security policy, and authenticate users and protect against common API security threats. And in the in the load balancer, focusing on ensuring like even distribution of the traffic and detecting routing traffic away from the unhealthy server. Because if we found this unhealthy server, so it will be not work what as expected result. Okay, so after SSL termination, we have a security feature. So in the reverse proxy, security should be like filtering malicious requests and protecting server from the direct exposure to the internet. And in the API gateway, security policy like authentications, users protect against common API security threats. For that, as a developer perspective, I'm using the like Azure Active Directory, or we have like JWT Bearer token, which we are applying for the securing purpose. Coming to the load balancer, for the ensuring the even distribution of the traffic and detecting routing traffic away from the unhealthy server. So this should be like as a security feature we are maintaining in the load balancer. Okay, next we have a protocol support. It's a very important task or very important policy. Like all this stuff, we have to be follow some rules to communication over the internet from the client to server. So everyone have a different protocol which they are supported. So we can see in the request in the reverse proxy, we have a support HTTP, HTTPS, and WebSocket. Coming to the API gateway, we have a support API specific like REST API or GraphQL on WebSocket. And in the load balancer also we have a network protocol including like HTTP, HTTPS, and TCP and UDP. And after all these important factors, we have to be use cases where we have to be use this one. So use for security for the reverse proxy like catching SSL termination, content manipulations, protecting server from the direct exposure. And for the API gateway, primarily used for the API management, enforcing security policy, rate limiting, and request response transformation. And the load balancer, it is primarily used for the distributing the traffic, ensuring the high availability, reliability, and efficient resource utilization. So this is the very important use cases of all these three. So as a single server can be configured to act as a reverse proxy, an API gateway, and a load balancer simultaneously. So in fact, in many real world scenario, these functionality often overlap, but many modern tools and software can serve in the multiple roles. Okay, so when we have to use what, I already mentioned here. For the reverse proxy purpose, if you need the security, caching, and SSL termination, use a reverse proxy. If you are managing API, enforcing security policy on there, and transferring the request response, use an API gateway. Next, we have a, like, if you need to distribute traffic among multiple servers, so use a load balancer. So this is the cases which we have to be use all these three scenario, or all these three type of uh, concept. Okay, and if you don't know, necessarily need separate server for each component. In many cases, a single server or cluster of server can handle all these roles. So modern server software and configuration allow you to set up this functionality on the same server. So the decision to use separate server might be based on the factor like, it is depend on the different requirement. If you have a big application, complex application, you can just create the different one. If you have a mid size to small, so you can create all the stuff in a single one also. So fault tolerance, scalability, specific performance requirement, basis on that we are creating. So after above property, now we have a architecture which is comparing as a monolithic versus microservices architecture. So monolithic architecture refer like a traditional approach where all the component of a software application are tightly integrated and packaged in a single unit. And it is a monolithic application we are knowing. But in the microservices architecture, it is an approach where large applications divided into small chunks, self-contained services that can run, scale, and deploy independently in a microservices based application. This is the best advantages of, because it is independently, it doesn't need a downtime. Like if I am deploying another one, will have to be like dependency over there for the deployment side. So it is like very good compared to monolithic architecture. Again, here also we have a difference from them. For the structure wise, in the monolithic architecture, we have an entire application in a single tightly integrated unit. But in the microservices architecture, it is divided into small independent loosely coupled services. Then for the communication purpose, inter-module communication. In the monolithic architecture, modules are closely connected and communicate directly with each other. But in the microservices architecture, independent services communicate via the well-defined API. Coming to the scalability, monolithic having like typically scale as whole, even if one model require more resources because it is a tightly coupled. That's why. But in microservices, can scale individual services independently based on the demand. Next, I have a technology stack. So same technology stack is used across the application, but in the microservices architecture, if I'm a developer as a Java developer, .NET developer, or Python developer, they can come across, and as a cross-functional team, we can work together and create one single applications. So it is using a different technology and programming languages. Coming to the deployment side, deployment in the monolithic we have a single unit, but in the microservices we have upgraded and scale independently. Flexibility, in the monolithic we have a limited flexibility. Changes may require modifying the entire applications, but in the microservices it is a high flexible. Services can be developed, deployed, and updated separately. And for the dependency purpose, models are interdependent, like changes in one model can affect others. But in the services, changes in one services don't affect the others. Development team wise, we can say in the monolithic, we have a single development team work on the entire application. But in the microservices, we have a multiple smaller team can work on different services simultaneously. Complexity-wise, monolithic simplicity in development but can be complex to modify and scale as the application grow. Complexity in management in the like microservices due to distributed nature, but provide a modularity and easier scaling. So it is a one way is a different, one way is a good one. fault isolation purpose, in the monolithic we have error in one model can potentially crash the entire application. And in the microservices, because it is independently, that's why error in one services usually don't affect the entire application, ensuring better fault isolation. And coming to the examples, in the monolithic we have a traditional web applications, early version of software system. And in the microservices we have a large scale application like Netflix, Amazon, and other internet scale platforms. So this is the various way we are comparing the both microservices and monolithic architecture, which is a best for which scenario. So the choices between monolithic and microservices architecture depends on the project size, complexity, scalability, needs, and development team resources. Microservices offer the scalability and flexibility but introduce the complexity, whereas monolithic architecture are simpler but might face challenges when the scaling a specific component is required. Okay, so when we have to use the monolithic use when we have a project is relatively small or simple. Rapid development and deployment are essential, and there's a small development team with the limited resource. Then you can go with the monolithic. In the microservices, the project is large, complex, and expected to scale significantly. Different parts of application require different technology, scalability, flexibility, and independence of services are critical. Then we can go with the microservices. So these all topics which is mainly fundamental and important points which we are covered as a HRD in the system design. Hope you got some information from this content. And if you have anything, any query, any point, any topic, please comment it down. I will try to solve and get the better version from this. Thank you.